When metal parts face the relentless forces of wear, corrosion, or accidental damage, industries are often confronted with a difficult choice: slow, expensive repairs or costly replacements. Traditional repair techniques like welding or thermal spray may restore surface integrity, but they come with their own risks, introducing excessive heat, altering the material's properties, and sometimes weakening what they strive to fix. In today's demanding industrial landscape, these compromises are less acceptable than ever. There's a transformative solution that's rewriting the rules of metal restoration: cold spray coating. Unlike conventional methods, cold spray harnesses the raw power of physics, not heat, to rejuvenate and protect metal surfaces. Using specialized equipment, technicians direct a supersonic jet of metal powder at the damaged area. Each tiny particle, driven by the force of compressed gas, smashes into the surface at breathtaking speeds. The energy of impact is so intense that the particles bond instantly, building up a dense, solid layer without ever melting the metal. This process isn't just a scientific curiosity. It's an engineering breakthrough that preserves the original properties of metals. No heat distortion, no oxidation, no unwanted changes in grain structure. On one side, you have traditional repairs, often leaving behind heat-affected zones, warped components, and residual stresses. On the other, cold spray delivers a flawless, heat-free restoration, ensuring the base material remains as strong as ever. The brilliance of cold spray lies in its simplicity and effectiveness. As the supersonic stream of particles pelts the worn or corroded surface, the kinetic energy is converted into a powerful mechanical bond. The particles flatten, deform, and stick, layer by layer, creating a new, resilient skin that seamlessly integrates with the underlying metal. The absence of high temperatures means sensitive parts retain their critical tolerances. There's no risk of softening, cracking, or introducing new weaknesses. Imagine a turbine blade eroded by years of service, or a hydraulic cylinder pitted by corrosion. With cold spray, these parts can be restored to their original dimensions and surface finish, sometimes even stronger and more resistant than before. The process is fast and adaptable, often performed with minimal disassembly and downtime. Repairs that once took weeks can now be completed in hours or days, keeping vital equipment in service and reducing costly interruptions. But the benefits go even deeper. Cold spray coatings are exceptionally durable, withstanding the harshest conditions: abrasion, impact, and chemical attack. The restored surfaces actively resist further corrosion, thanks to the dense, non-porous nature of the deposited layer. And because the process is so precise, it allows for selective repair. Only the worn area is treated, preserving the rest of the part and minimizing waste. Industries around the world are embracing cold spray for its unmatched combination of speed, strength, and versatility. In aerospace, technicians use it to repair landing gear, engine components, and structural elements, returning aircraft to service without the delays of traditional welding or replacement. The automotive sector restores engine blocks, transmission housings, and other high-value parts, often enhancing their performance and longevity. Heavy industry relies on cold spray to maintain pumps, valves, and rollers, extending the life of critical assets and slashing maintenance costs. Even in the unforgiving environments of oil and gas rigs, where corrosion and abrasion are constant threats, cold spray delivers reliable protection. It shields exposed surfaces from saltwater, chemicals, and extreme temperatures, ensuring that equipment runs smoothly and safely. The result is a dramatic reduction in unplanned downtime and a boost in operational efficiency. Cold spray technology isn't just about repairing what's broken, it's about innovating for the future. Engineers are developing new alloys and composite powders, unlocking superior properties for specific applications. The process can be tailored to build up worn surfaces, apply protective coatings, or even create entirely new shapes and features. As research continues, the possibilities expand, opening new frontiers in additive manufacturing and advanced surface engineering. The environmental impact is another critical advantage. By enabling the reuse of existing parts, cold spray reduces the need for energy-intensive manufacturing and the consumption of raw materials. Waste is minimized and the carbon footprint drops. For industries seeking to meet stringent sustainability goals, this is a powerful incentive. Consider the life cycle of a typical industrial component. Years of service lead to gradual wear until a critical failure threatens to halt operations. Traditionally, the part would be removed, scrapped, and replaced, an expensive and resource-hungry process. With cold spray, the same component can be restored to its original specifications, extending its useful life and maximizing its value. It's a smarter, more sustainable way to manage assets. The adoption of cold spray technology is accelerating, driven by its clear advantages. Maintenance teams appreciate the rapid turnaround and reduced downtime. Engineers value the preservation of material properties and the improved performance. Financial managers see the significant cost savings, both in direct repairs and in the prevention of catastrophic failures. Training and implementation are straightforward. Operators use portable or stationary cold spray systems, guiding the nozzle over the damaged area with precision. The process is clean and safe, with no toxic fumes or open flames. Quality control is built in, with real-time monitoring of coating thickness and adhesion. The result is a consistent, high-quality repair that meets the most demanding industry standards. For manufacturers and repair facilities, cold spray unlocks new business opportunities. Components that were once considered unrepairable can now be salvaged and upgraded. Custom coatings can be engineered for specific challenges: high wear, electrical conductivity, thermal insulation, or corrosion resistance. The technology is adaptable to a wide range of materials, including aluminum, copper, titanium, nickel, and advanced alloys. As industries look to the future, the need for reliable, efficient, and sustainable repair solutions has never been greater. Aging infrastructure, supply chain disruptions, and the push for greener operations all point to the advantages of cold spray. It's a technology that embodies the principles of modern manufacturing: precision, speed, and respect for resources. In the world of aviation, every minute an aircraft spends on the ground is costly. Cold spray is revolutionizing maintenance by enabling rapid on-site repairs of landing gear, engine casings, and structural supports. The restored parts not only meet stringent safety requirements but often exceed the performance of their original counterparts. Airlines keep their fleets in the air, passengers reach their destinations on time, and the industry as a whole benefits from reduced waste and improved reliability. In automotive manufacturing, cold spray is used to repair cylinder heads, turbochargers, and exhaust manifolds. It allows for the restoration of tight tolerances and critical surfaces, reducing scrap rates and lowering production costs. Performance vehicles benefit from custom coatings that enhance thermal resistance or reduce friction, pushing the boundaries of speed and efficiency. Heavy machinery, from mining equipment to construction vehicles, faces constant stress and abrasion. Downtime for repairs can halt entire operations. Cold spray offers a lifeline, restoring worn surfaces and reinforcing weak points without lengthy delays. Equipment stays in the field longer, maintenance crews work more efficiently, and businesses maintain their competitive edge. Oil and gas platforms, where exposure to salt water and harsh chemicals is unavoidable, benefit from the corrosion-resistant properties of cold spray coatings. Pipelines, valves, and drilling equipment are shielded from the elements, extending their operational life and reducing the risk of leaks or failures. The technology supports both preventative maintenance and emergency repairs, ensuring the smooth flow of vital resources. Even in emerging industries like renewable energy, cold spray is finding applications. Wind turbine components, solar panel frames, and battery housings can all be repaired or enhanced with tailored coatings. As the demand for sustainable energy grows, the role of advanced manufacturing technologies like cold spray will only become more important. The science behind cold spray continues to evolve. Researchers are exploring new powder formulations, optimizing gas flow dynamics, and refining deposition techniques. The result is greater efficiency, higher adhesion strength, and expanded compatibility with challenging materials. As understanding deepens, the range of possible applications grows, fueling innovation across multiple sectors. For technicians and engineers, mastering cold spray opens up a world of possibilities. It's a skill set that combines precision, creativity, and a deep understanding of materials science. Each repair is an opportunity to push the limits of what's possible, to deliver value in ways that were once unimaginable. At its core, cold spray is about more than just fixing what's broken. It's about building a smarter, more sustainable future for manufacturing and maintenance. It's about harnessing the power of high-speed impact to create lasting solutions, protecting the investments that drive our world forward. Picture a newly restored turbine blade gleaming under inspection lights. Its surface is flawless, its structure uncompromised, its life extended by years. This is the promise of cold spray, a high-speed, high-impact solution for the challenges of modern industry. It's transforming the way we think about repairs, replacements, and resource management. As industries face ever greater demands for reliability, efficiency, and sustainability, cold spray stands out as a game-changing technology. It's reshaping the landscape of manufacturing and maintenance, delivering results that were once out of reach. From aerospace to automotive, from heavy industry to energy, cold spray is keeping critical components in top shape. It's restoring strength, resisting corrosion, and saving time and money, all while preserving the integrity of what matters most. In a world where every second counts and every resource matters, cold spray coating is proving itself as the solution for today's and tomorrow's manufacturing challenges.